Hello everyone, welcome back to my channel Simplified Dentistry with Dr. Maheen K, and today we'll be discussing the topic of direct retainers in detail. So what is basically a direct retainer? A direct retainer is considered as a part of the removable partial denture that is used to retain, prevent dislodgement, and consist of clasp assemblies and precision attachments. Okay, so basically it is a component of RPD that engages abutments and resists the dislodging forces. So to remember this definition, I have a trick. We can write RPD here, and R stands for resisting forces, right? P stands for prevention or preventing, and D stands for dislodgement, right? And it consists of clasp assemblies and precision attachments. So RPD plus CA and PA, resisting and prevention of dislodging forces, consisting of clasp assemblies and precision attachments. Now we'll be discussing the classification of the direct retainers. The direct retainers can be divided into the extracoronal and the intracoronal. As the name suggests, the extracoronal means outside the limit of the crown, whereas intracoronal means within the confines of the crown. The intracoronal can be special attachments, bar attachments, stud attachments, internal attachments, and external attachments. Intracoronal direct retainers are often discussed as the precision attachments and the non-precision attachments. This was suggested by Herman in 1906, right? So what are the precision and non-precision attachments? The precision attachments are the one which are done or manufactured in a highly uh, precisioned way or precised form, and they have parallel walls, whereas the non-precision attachments are first made out of wax, and then the plastic pattern is made usually, and that is followed by the metal cast. It is less precise obviously, and it has slightly tapering walls. Coming to the extracoronal attachments, they can be further divided into the manufactured forms and the custom made forms. The manufactured form is often done by the company name as Delbo, whereas the custom made form is further divided into gingivally approaching and occlusally approaching. So, another name for gingivally approaching is infrabulge. You must have heard of this. Infrabulge clasp. Whereas another name for occlusally approaching is suprabulge clasp, right? So the infrabulge clasp, the examples are barclasp and roachclasp, whereas the suprabulge clasp are the circumferential clasp and the aker'sclasp. Okay, so now we'll be discussing the components of the direct retainer. This is a rough diagram, and there are 6 basic components of the direct retainer. So firstly, we have the retentive arm. This is the retentive arm, and this is the retentive tip or terminal, right? And this is the reciprocal arm. I have numbered it, right? 2 is the reciprocal arm. 3, these are the shoulders, right? The body, this part is the body. The rest, this is the rest, right? And this is the minor connector, right? So what happened is that the retentive arm is basically divided into 2 parts, the retentive terminal, and this retentive terminal is basically very flexible because it has to go under the height of the contour, right? So the retentive tip and the terminal and the retentive clasp arm makes the retentive arm all together, right? Opposite to the retentive arm, we have the shoulder. Sorry, we have the reciprocal arm. Reciprocal arm is basically there to reciprocate the forces that are applied to the retentive arm, right? And then it is these two forms, the retentive and the reciprocal form, are connected to the body through the shoulder, right? These are the shoulders, and this connect the retentive and the reciprocal arms to the body. And lastly, the body connects the rest and the minor connector along with the shoulder. So the body basically connects the rest seat and the shoulders to the minor connector, right? Okay, so now we'll be discussing the functions of the direct retainers. So the functions that are expected out of the direct retainer is retention, reciprocation, stability, and support. So retention, reciprocation, and stability is usually provided by the clasp arm, but stability is also provided by the reciprocal arm, right? And the support is provided by the rest seat, right? Now, what will be the functional requirements that are expected out of any direct retainer that is to be made? First and foremost, functional requirement, as we discussed before, is retention. Now, how can the retention be achieved? First of all, the length of the clasp arm really matters. How? Because as we discussed previously earlier, that flexibility is directly proportional to length cube. That means the flexibility will go up if the length goes up, right? This means the flexibility will increase if it has a longer clasp arm. Then coming to the diameter of the clasp arm. The diameter is inversely proportional to flexibility. That is, if the diameter goes up, the flexibility will come down. Material. Now we have discussed the materials here in the descending order. The most flexible considered are the wrought alloys. However, the gold alloys are considered less flexible as compared to the wrought alloys, and the least flexible are considered the cast chrome alloys. Lastly, the cross section. If the cross section is circular, they tend to be more flexible since it can flex in the all planes. However, if the cross sectional is semicircular, the flexibility decreases as there is limit of flexing into different kind of planes. So now what are the other functional requirements other than retention? Stability. Stability is often provided by the reciprocal arm, right? And it has to resist the horizontal displacement forces of the direct retainer, right? Then we have support. Support is provided by the rest seat, right? It resists the gingival displacement of the direct retainer. How? Because we put the rest onto the occlusal surface of the teeth, right? So the function is to prevent the vertical or gingival displacement of the direct retainer. Then comes the encirclement. Encirclement is basically a way which the direct retainer embraces a tooth. It has to be greater than 180 degrees and it can be a continuous contact whereas a broken contact. Now, what would be the broken contact? It has to be at least 3 points, that is the retentive tip, right? The rest seat and the reciprocal arm tip. These are the least 3 point contacts that has to be maintained in the broken contact. What are the examples of the continuous contact? We have the circumferential clasp, right? And in the broken contact, we have the barclasp and the roche clasp. Right. Then comes reciprocation. This is basically to counterbalance the forces that are applied by the retentive arm. And lastly, the passivity. The passivity helps the clasp or the direct retainer to remain in a passive state that in the absence of any function, right? So this is how we wrap our direct retainers. Hope you like the video. We have tried to put all the information together in a concise form. Please like, share and subscribe and stay tuned for more videos.